Okay, boys and girls, today our objective is I can use mental math strategies to add greater numbers. So I'm going to show you 3 different mental math strategies for addition. These are not the only 3 ways that you can add numbers in your head. These are 3 that you were previewed in 3rd grade with smaller numbers, and I'm going to show you how you can use the same strategies with greater numbers. So we're going to use the same problem for all 3 strategies, and it's going to be 2,548 plus 3,552. Okay. The first strategy that I'm going to show you is called break apart strategy. And this really builds on expanded form that you learned in topic 1 of 4th grade. Expanded form is when you look at each number and you break it into its place value quantities. So 2,548 would break apart into 2,000 plus 500 plus 40 plus 8. And 3,552 would break apart into 3,000 plus 500 plus 50 plus 2. So you may already see some ways that this is going to come together into addition. This is another way of almost pulling apart the digits and giving them the zeros that they have. So like, for example, in the number 2,548, this isn't a 4. It's a 4 in the tens place, so it's actually a 40. And so writing it this way gives us a chance to work with it as the quantity that that 4 represents. So I'm going to rewrite this where we add the thousands together, the hundreds together, the tens together, and the ones together. So 2,000 plus 3,000 is 5,000. 500 plus 500 is 1,000. 40 plus 50 is 90. And 8 plus 2 is 10. Now I'm going to put these two together first because that equals 100. Then I'm going to put these two together because that equals 6,000. Then I'm going to add those together to get an answer of 6,100. So the answer to the problem 2,548 plus 3,552 is 6,100. I'm going to show you how to get the same answer with 2 more strategies. So again, this strategy is called break apart. Okay. The next strategy that I'm going to show you is called friendly numbers. And for friendly numbers to be an effective strategy for you, you have to know numbers that come together that make tens, hundreds, thousands, or friendly numbers could also be things like doubles or numbers that end in 5, ways that you know how to combine numbers so that you get easy to work with numbers like tens or 25s. So I'm going to show you that in this problem, there actually are some friendly numbers that you can see, but you might have to break them apart a little bit. So I'm going to write these a little bit bigger. And the first thing that I noticed is 48 and 52 would go together friendly because 48 plus 52, I immediately saw I could make this a 50 by getting the 2 from over here. And if I did that, then I would only have a 50 left. No, that's not right. There we go. There's my 50 that is left. And 48 plus 2 plus 50 is 100. Some kids would break this apart into number bonds that look more like this. I know this is what the kids do in 2nd grade. And then they would put the 8 and 2 together to get a 10, the 4 and the 40 and the 50 together to get a 90. and equal 100. But either way, however you get there, it's okay, because hopefully students are starting to see that 48 plus 52 would be 100. All right, so the first friendly number there I saw was in the tens and ones. So I would end up with 48 plus 52 equals 100. And that leaves me just left with my thousands place and my hundreds place of each number. So I could look at that as just doing 25 plus 35. That would be one choice. And for a lot of kids, those are friendly because fives add together easily in our head. 5 and 5 would give me a 10. 3 and 2 would give me 50. 10 plus 50 would equal 60. The tricky part here is that it's not 61s. It's not even 60,000s. It's 60 hundreds. And that part's kind of tricky to explain. So you might want to be careful with friendly number strategy here if you're not super comfortable with place value yet. All right, so some kids aren't seeing this as 35 hundreds and 25 hundreds now equaling 60 hundreds, or 60 hundreds being the same thing as 6,000. But if you are a kid who already sees that, then you're in good shape because now you have an answer of either 60 hundreds plus one more hundred, which would be 61 hundreds. Or the other way we say that would be 6,000s plus 100, which would give me an answer of 6,100, which we already know is correct from using the break apart strategy. Okay, and the last option, by the way, your student may see different friendly numbers here, and that's okay too. The last option I'm going to show you is an open number line. This can be a little bit tricky with greater numbers because of the size of your sheet of paper. In my case, my whiteboard, it's not very big. So knowing that I'm starting with such large numbers, I have to be kind of particular about what number I'm going to start with, what size jumps I'm going to make, or I don't have room to record my thinking. That actually is really important. If you can't keep track of it, then it's not going to be an effective strategy for you. One tip I most of the time give my students when they're doing addition on an open number line is to start with the greater number. It's kind of an easy thing to think about because the greater number, you're going to add less to it because the other number is already less. So you're going to do a little less work. So I'm going to start with 3,552 on my open number line. Now I know I need to add 2,548 to it. A lot of kids like to start in the greatest place value on an open number line versus if this were standard algorithm where you would add the ones and ones, tens and tens. Either way is fine. I'm actually going to start with the thousands place. So my first two jumps on my number line are going to be larger. And they make up the 2 and 2,548. So if I were on 3,552, 1,000 more would be 4,552, and another 1,000 after that would be 5,552. Okay, so now I have taken the 2,000s and I have made my jumps. Now I'm going to look at the next place value where I'm going to jump up 500s. So I'm going to make smaller bumps, as I am in the hundreds place now, 3, 4. And I'm jumping up 500s. So some kids like to write it each hundred. Some can keep track by just writing plus 500, whichever works for your student. Now I'm going to count by hundreds from 5,552. So this would be 5,652, 5,752, 5,852, 5,952. Ooh. What happens when I make the next jump? 6,052. All right, so now I've accounted for my 500s. Now I need to count up 40 because of my 4 and the tens place. These are going to be much smaller jumps. Yes, I'm running out of room. So I have a 5 in the tens place, and I need to jump up 4 more tens. So it'd go 52, 6,062, 6,072, 6,082, 6,092. And then this is where I really get into trouble with this tool. I'm out of room, but I do only need to make a jump of 8 more. Just don't know if I can get them all on here. 1, 2, 3, 4, 5, 6, 7, 8. It's very tight. So I have 6,092, and I'm going to count up 8 more. 6,093, 6,094, 6,095, 6,096, 6,097, 6,098, 6,099, 6,100. So I kind of ran out of room at the end to show my +8. I was afraid that would happen. But it does show that you still get to the same answer of 6,100. So these are 3 strategies that you can use for mental math to add greater numbers.